Hi students, hope you all are safe at home. As the present situation is critical, we are planning to conduct online lectures. So, kindly use this opportunity and try to understand the concepts clearly. Last class we discussed about the topic balancing a chemical equation. Before moving on to the next topic, let's recollect the previous topics which we have already discussed in this chapter. The first topic which we have discussed is chemical change. Chemical change means a new product is formed there. The specialty is that we can't reverse the new product into the previous one. After that, we discussed about chemical reaction. That means the base points about the chemical reaction we have discussed. In a chemical reaction, there should be a reactant and product. The reactants combine together to form products. Basically, we can say that it is a chemical reaction. Then we have discussed about how to balance a chemical equation. So for balancing a chemical equation, we are following one major law, that is law of conservation of mass. The law of conservation of mass states that energy can neither be created nor be destroyed in a chemical reaction. That means the number of the atoms in the reactant side and the product side should be equal. We follow some steps for balancing the chemical equation. Now we are moving on to our next topic, that is types of chemical reactions. Before moving on to our next topic, I request all of them to open your textbook, page number 6. The reactants combine together to form a product. It is termed as chemical reaction. So mainly there are 4 types of chemical reaction. The first type of chemical reaction is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. And the fourth one is double displacement reaction. Now we are going to discuss about the first type of chemical reaction, that is combination reaction. Reactions in which 2 or more reactants combine to form one product are called as combination reaction. Here, from the definition itself, it is clear that when 2 or more reactants react together, a single product will be formed. Those type of reaction is termed as combination reaction. In this slide, you can see the general representation of combination reaction. A plus B, which gives C. Both A and B represent the reactants and C represents the single product. Here the pictorial representation of combination reaction also you can see in this slide. For understanding more about combination reaction, here is a small demonstration of combination reaction. Here we are going to explain combination reaction with a simple experiment. Combination reaction means when 2 or more reactants react together to form a single product. It is termed as combination reaction. So as the present situation, here chemicals are not available. So here I am going to explain this combination reaction with coffee powder as one of the reactant and water as another reactant. So here we are going to take a small beaker. Into this beaker we are adding 10 ml or 20 ml of water. To this we are adding 1 spoon of coffee powder. Then stir it well. Here you can see that one reactant has water and other reactant has coffee powder. When both this reactant react together to form a single product. Now we are going to discuss about some of the examples of combination reaction. First example is the formation of silicate lime. Silicate lime means calcium hydroxide. In your textbook, page number 6, you can see one activity, that is activity 1.4. So for doing this activity, we need 2 reactants. That is, first one is calcium oxide, CaO. Calcium oxide is also known as quicklime. The common name of calcium oxide is quicklime. The second reactant is water. For doing this reaction, we are taking one beaker. To that beaker, we are adding 10 ml or 15 ml of water. To the beaker which is containing water, we are adding some drops of or 1 spatula of calcium oxide. Calcium oxide is in solid state. After adding calcium oxide to the beaker, stir the beaker well. After that, you can see that both the reactant, that means the CaO, calcium oxide and water, react together to form one single product, that is calcium hydroxide. Calcium hydroxide, the common name of calcium hydroxide is Slakert lime. This is the first example for combination reaction. The second example for combination reaction is burning of magnesium ribbon. I think that you are familiar with this activity. We had already done this activity from our school laboratory. So for doing this activity, we need two reactants. First one is magnesium ribbon and the second one is oxygen. It is in the atmosphere itself, we can say the oxygen. So we are taking magnesium ribbon and we are burning that magnesium ribbon in the presence of oxygen. So when magnesium is burnt in the presence of oxygen, here two reactants is reacting together and it forms a single product, that is magnesium oxide, MgO. When the magnesium is burnt in the presence of oxygen, you can see some ashes are produced there. That ashes is termed as magnesium oxide. Now we are going to discuss about the third example, that is reaction of carbon and oxygen. Here the two reactants, first one is carbon and the second one is oxygen. When carbon and oxygen gas react together, it forms carbon dioxide gas. These are some of the examples of combination reactions. Now we are going to study about exothermic reaction and endothermic reaction. Exothermic reaction means the reaction in which heat is released along with the formation of products. That means in this reaction, the products will be formed there. Along with that product, the heat energy will be released during that reaction. The first example is burning of natural gas. Natural gas means CH4. It is also known as methane. So when methane gas is burnt in the presence of oxygen, excess amount of heat energy is released and the products formed there is carbon dioxide and water. This is the first example for exothermic reaction. The second example is decomposition of vegetable matter. The decomposition of the vegetable matter into compost is also an example for exothermic reaction. So exothermic reaction, basically it is known as when the reaction is formed there, the heat energy will be released. Those type of reaction is termed as exothermic reaction. Second type of reaction is endothermic reaction. Reaction in which heat is absorbed along with the formation of the products. Here in this reaction, the product will be formed there. Along with the product, the heat energy will be absorbed. In exothermic, the heat energy is released and in endothermic reaction, the heat energy is absorbed. An example for endothermic reaction is melting of ice cube. Second type of chemical reaction is decomposition reaction. Decomposition reaction means reaction in which one compound decomposes in two or more compounds or elements. That means here we are taking one compound and that compound will be breaking down into simple products. Those type of reaction is termed as decomposition reaction. Here simple reactants break down to form simple products. The general representation of decomposition reaction is given in your slide. AB, that means AB is one single reactant that react together to form simple products. That means more than one product will be there. Those type of reaction is termed as decomposition reaction. The pictorial representation of decomposition reaction is also given in the slide. Next, we are going to discuss about the types of decomposition reaction. The first type of decomposition reaction is thermal decomposition reaction. From that word itself, it is clear that thermal means heat. So, in this decomposition reaction is done with the help of heat energy is termed as thermal decomposition reaction. Second type of decomposition reaction is electrolytic decomposition reaction. Here, this decomposition reaction is done with the help of electricity. And the third one is photolytic or photolysis or photo decomposition. Here, this type of reaction is done with the help of sunlight. These are the main three types of decomposition reactions. First type of decomposition reaction is thermal decomposition reaction. Thermal decomposition reaction means single reactants break down with the help of heating to form simple products. That means the decomposition of substance on heating is termed as decomposition reaction. Here we can explain thermal decomposition with the help of one example, that is heating of FeSO4 crystals. FeSO4 means ferrous sulfate crystals. The color of ferrous sulfate crystals is light green color. You can see the picture of ferrous sulfate crystal in the slide itself. So we are going to take one test tube. Into that test tube we are adding ferrous sulfate crystals. 1 spoon of ferrous sulfate crystals we are going to add. Then we are heating that test tube which is containing ferrous sulfate crystals. After some times you can see that a fuming gas is coming outside from the test tube. So when you have a look at that test tube, you can see the color of ferrous sulfate crystals gets changed. So this represents that ferrous sulfate crystals changes to Fe2O3, that is ferric oxide. Along with that ferric oxide, two gases is also formed there, that is SO2 and SO3. Here in this experiment we have taken one reactant only, that is FeSO4. When we heat that FeSO4 crystals, at that time that single reactant through heating it get converts to simple products. That means more than one product is formed there. The first major product is Fe2O3, that is ferric oxide. Second one is SO2, that is gaseous state, that is sulfur dioxide. And the third one is SO3, it is also in gaseous state. After this experiment, you can see that the color of FeSO4, that is green color, get converted to black color, that means light black color. That light black color represents the ferric oxide. This is the first example for thermal decomposition reaction. That activity is given in your textbook also, activity 1.5. Next, below to that activity, you can see one more example, that is CaCO3. What happens when CaCO3 is getting heated? CaCO3 means the chemical name of CaCO3 is calcium carbonate and the common name of CaCO3 is limestone. We are taking CaCO3 in a test tube and we are heating that CaCO3. At that time, it gets converted into two main products, that is CaO. We have already discussed this CaO in previous example, that is CaO means quicklime. Along with that quicklime, the second product is carbon dioxide. So when CaCO3, that is limestone or calcium carbonate, is heated, it get converted to two products, that is CaO, that is quicklime. Quicklime is in solid state and the second one is CO2, that CO2 is in gaseous state. Another example is also given in your textbook, that is activity 1.6. Take about 2 gram lead nitrate powder in a boiling tube, holding the boiling tube with a pair of tongs and heat it over the flame. You can observe that the color of the lead nitrate powder get converted. The equation is given in your textbook. Please have a look at that equation, page number 9. You can see that equation. 2 PbNO3 twice, that PbNO3 twice is lead nitrate and the color of lead nitrate is yellow. When we are going to heat that lead nitrate, it gets converted into the oxide form, that is lead oxide. Lead nitrate is in solid state. When we heated that lead nitrate, it gets converted into three main products. First one is lead oxide, that lead oxide is in solid state. Second one is nitrogen dioxide, it is in gaseous state, and the third product is oxygen, that is also in gaseous state. So along with one solid state product, two gaseous state products is also there. I think that reaction is very clear for you. The third type of decomposition reaction is electrolytic decomposition reaction. Electrolytic decomposition reaction means here the reaction in which compounds decompose to simpler compounds on passing of electricity. That means here a compound is decomposed into other products only by the passage of electricity. We can discuss one example. One activity is given there in your textbook, that is page number 9, activity 1.7. That activity represents the electrolysis of water. A picture also you can see in the slide. I'm going to explain about the activity. Drill 2 holes at the base of a mug. Insert 2 carbon electrodes into these holes using 2 rubber stoppers. After that, we are going to connect 2 electrodes to a 6-volt battery. Immerse the electrodes in water by filling the mug with the liquid. Add a few drops of dilute sulfuric acid into the water. The reason of adding dilute sulfuric acid into the beaker is pure water is not a good conductor of electricity. Here dilute sulfuric acid works as a catalyst to divide the water into H plus and OH minus ions. Invert 2 water-filled test tubes over the carbon electrodes, then switch on the circuit. We can see that gas bubbles appear in both the test tubes. There is a level of rise in the level of water in both the test tubes to different extents. After that, carefully remove the test tubes completely filled with gases. Then bring a burning candle near the mouth of both the test tubes to test the gases. We can see that the candle continues to burn in the presence of gas coming from the first test tube. On the other side, the candle puts off by the gas coming from the second test tube. In this reaction, the compound water decomposes or breaks as a reactant by the passage of electricity. This reaction requires energy in the form of electricity and is endothermic in nature also. Hydrogen is the first product which puts off the flame, and oxygen is the second product in this reaction which allows the candles to burn. You can see the equation also in this reaction. 2H2O, which gives electricity decomposition, that means the catalyst, it is electricity decomposition, which gives 2H2 plus O2. Here water splits to form two products, that is H2 and O2. Both hydrogen and oxygen are gases. Next type of decomposition reaction is photodecomposition or photolysis or photolytic decomposition reaction. Here in this decomposition reaction, the reaction in which a compound decomposes by the help of sunlight is termed as photolysis or photodecomposition. We can explain this reaction with the help of an example. An activity is given in your textbook, that is activity 1.8. Here we are taking silver chloride in a watch glass. After taking that silver chloride in a watch glass, observe its color. Place the watch glass under sunlight for some time. Here we can see that the color of silver chloride changes. In this reaction, the compound silver chloride decomposes or breaks as a reactant under sunlight. This reaction requires energy in the form of sunlight. This is why it is called as photolytic reaction, and it is an endothermic reaction also, because here the energy is absorbed. That means the sunlight is absorbed in this reaction. So we can term or we can call this reaction as an example for endothermic reaction also. The equation is shown in the slide. 2AgCl in the presence of sunlight, which gives 2Ag plus Cl2. Ag is the first product and Cl is the second product that is liberated in the form of gas. Today we discussed about some of the main points. First one, we discussed about chemical reactions. After that we discussed about types of chemical reactions. There we discussed first one, combination reaction, second one, decomposition reaction. Along with decomposition reaction, we discussed three types of decomposition reaction also. First one is thermal decomposition reaction, second one is electrolytic decomposition reaction, and the third one is photolytic decomposition reaction. And we discussed all those activities also. So students, I hope that all the concepts are clear for you. Read your text 2 or 3 times and do all the activities also. Thank you.